schedule, still have 15 minutes to go for, so because we already something went inside, there is some discussion, especially for the Miyabi's memory system. But any other open discussion here is a good chance to where the DK is joining us. Or from online, if anyone have had a question or comment or some suggestion for the discussion. No? Okay, so that I'm personally, I a little bit talk about that. I'm very now curious about memory system is a GPU and CPU combination. What I mean is the GH200 versus MI300A. So in the last SCA in the Singapore on March, I discussed with Bronis Depinski, and he's of course on the side of the MI300A because he's a lowest memory. So he said that it is a very bad idea to have a hybrid memory or a different kind of architecture of the memory of the GPU and the CPU because the HBM can cover everything, like there are of course the GPU and also the CPU. And actually MI300A, as my memory is correct, HBM3 performance is higher than the GH200 of the 40 byte per second.
Number of memory stack.
Yes, because number of memory stack is larger, and also that it's about 6 gigabytes per second. If I will check it.
Point something.
I'll check it because I must talk about it day after tomorrow here. So anyway, and but I have a little concern that really the single flat HBM is perfect for the covering both the CPU and GPU together. So we have some experience. For example, Fugaku A64FX has 32 gigabytes of the HBM only. And that is a very good memory. At that time, it wasn't compared with today's technology. It was 1 terabyte per second, but 1 terabyte per second at that time was very excellent. Now it's a 4 or a 5 terabyte per second. And also Miyabi-C, today there is no talk about the Miyabi-C, but the Miyabi-C is also equipped with the HBM version of the Sapphire Rapid. And how much is the memory capacity?
128.
For socket?
Yeah, per node.
Per node. So two sockets cover 128 gigabyte.
Yeah.
So single socket has a 64 gigabyte. Okay. So the 128 gigabyte. So we already have some experience of the CPU only system HBM and in the both Fugaku system or Sapphire Rapid HBM. But really, we don't have any data on the hybrid CPU GPU sharing of the HBM. So do you have anything, any idea or any data about or comment?
No, I think the only access we had is this MI300. That is the kind of we have done some initial studies, just like what you have done for the Grasshopper. But after that, I don't know. I mean, the AMD also announced 345 or 350, MI350. So I don't know the architecture yet.
I heard that is not the APU.
Okay. Yeah.
No, sorry. Don't please forget my.
So I have a comment.
Yes.
So actually, so the operation system perspective, so the DDR memory is much better for the latency. So basically, HBM is a so larger latency to access the memory. So we already had the experience at the KNL for the MCD RAM.
Very bad memory.
Yeah. The memory of memory.
My memory means that our mind.
Okay. Yeah.
Very bad experience.
Yes.
So long with booting time.
Yeah. So in terms of such characteristics, so the Gracehopper is so suitable for each part. So the Grace has a DDR related memory, and so Hopper has a HBM. So that is very good combination, I think. So that I wonder whether MI300A can achieve such kind of a good performance.
Do you University of Tokyo side have some experience of the Sapphire Rapid HBM?
Yeah. So Sapphire Rapids HBM is very good for the very wide range of use, but also slightly strange characteristics between the cache behavior and the memory behavior. So in some case, the main memory much better performance than cache memory. So the slightly confusing for the performance.
So honestly saying that University of Tsukuba is not so much care about the Yabc because we already shifted perfectly to the GPU solution. And one more thing, my concern about HBM sharing by CPU and GPU is that anyway, so CPU and GPU's behavior is totally different. And also cache line size is different. And so, but it is just connected to the very wide, large tile of the HBM3. So I'm really curious about many the case of the access. And of course, it is good because there is no need for the data transfer anymore. And on the other hand, my concern about the SAM is that SAM is good, SAM is good to have an automatic page migration. So my concern is that perhaps we waste the memory capacity because page are almost for example, if all the pages are allocated in the DDR side, Grace side is totally moved to the Hopper's HBM side, and the DDR side is empty, it's okay. But in my understanding, it still remain or at least keeps the address space of, because address space is single. So if the page becomes free on the DDR side, you can enjoy it at full 128 gigabyte. Otherwise, even we have 128 gigabyte on the DDR and 96 gigabyte on the HBM, but most of the memory is duplicatedly consumed, and the user can only access maybe just a 90 gigabyte or something. Even physically, we have over 200 gigabyte. So, in our experience that as shortly Fujita-san mentioned, that so far we didn't observe any pushback from the HBM to DDR by the reverse side of the SAM mechanism, page migration. Because I think one of the reasons is that even HBM side of the memory is still used continuously exist. CPU side access is not so bad because on NVLink C2C is very fast. Only the latency is a problem. But the cache will maybe cover some latency problem. So in that case, another question, why we should have a DDR? But as Hanawa-san said, the DDR is still required for the many of the ordinary operation and operating system and the booting and so on. So in current situation, I think there is no good solution or conclusion and which one is good. So fortunately, University of Tsukuba will have a new system on the next February. We can really fairly compare. And from February, Tsukuba is the only one national university who has both the NVIDIA system and the AMD system. That is curious. So anyone, and we really welcome, not just for the application execution, but also for the system side research in our center. Any other comment or some objection or something? Okay?
Yes.
Yes, please.
Going back to your question, I mean, if you see NVIDIA, I mean, they are so much heavy on GPU now, they don't care about CPU or the DDR memory, right? So, because they only want AI workload, okay? In fact, they even don't care about HPC these days. It's yeah. So I think, I mean, the DDR is still being put on the CPU just as a backup. But they also have a plan, in fact, to totally remove CPU, right? Like use like Bluefield or some lightweight ARM core with some memory just for booting, those kind of things. So we may see the architectures totally changing over the years, unless a lot of applications still can only run on CPU. They don't have any GPU variation. Then we'll see like there will be a split in the market saying these are CPU based systems and these are GPU based systems.
So in that point, yes, and I also almost agree, but when we decided to introduce the GH200 for the Miyabi G, one question is that we will, always, if we introduce the GH200, always the Hopper GPU is beside with the 72 core of the Grace. So far, as maybe Nandi-san mentioned today, so far we have a 1-2 solution or 2-4 solution or something. So we thought in the GPU system, CPU is a kind of the take care of the GPU or booting the node or something. So number of the CPU core is maybe not so important like a 72. So actually, the Kisti in the South Korea announced that in the last May, they will introduce a really big GH200 based system. And it is about 8 times larger than the Miyabi G. So it's they're watching about 500 petaflops peak performance range, and also have a very good budget. I'm not sure that the current government is still continue to do that, but anyway, so that they had the same kind of the discussion. The really the CPU core, too much CPU core, perhaps with the GH200, and that is also, on the other hand, MI300A, we have only 24 cores, I think, compared with a very big S300 GPU side. So I'm also curious about if the future direction of NVIDIA, it is quite difficult to eliminate absolutely the CPU, but maybe they will reduce number of cores. So that the NVIDIA guy is just quiet, but.
So one possibility. One possibility is DPU will replace CPU.
Yeah. CPU is just on the network side.
Yes.
The other side is only the GPU.
Yes.
That
can be one way. Yeah.
Okay, interesting.
Actually, DJ3 is GPU using some CPU part storage.
So what I mean is that CPU is still required, for example, as Hana-san just talked, storage access is very important. But maybe that is enough by the DPU. So DPU is connected to the InfiniBand, and the storage system is also connected by the InfiniBand. So DPU is enough for the storage control. Another interesting idea. Okay, we reached the 40 minutes, so it's time's up. So thank you very much today, and DK and Fujiya-san and Sumo-san and all attendees. It's very interesting talk. Thank you very much.